to introduce you to David Alaband.
Thank you, Michaela. Good afternoon, and thank you for taking the time out of your day to join us for this webinar on demand control ventilation, indoor air quality and energy savings, with special focus on how Belimo sensors can support with optimum indoor air quality within the applications. We breathe 424 cubic feet of air every single day. Do we ever stop to think how good is the quality of this air and how it affects our health? One more important question we should consider is, where do we spend most of our time? We spend approximately 90% of our time indoors, and buildings have a unique ability to positively or negatively influence our health. So much time is spent indoors. Do you think we really live comfortably and healthy? First, let's take a look at some of the different types of indoor air contaminants we are subject to on a daily basis. Contamination can be generated by humans and emissions through various sources. For example, through the breath, through skin, respiration, flatus, through cosmetics and household supplies. Also different combustion methods, including engines, appliances and tobacco smoke. Building material, furniture, office equipment also plays significant roles in producing indoor air contaminants such as paints, solvents, PVC, and through printers and copiers. Typical substances generated from both those emission sources include a mix of VOCs, CO2, humidity, methane, formaldehyde, benzene, and so on. CO2 levels, which are not often noticed or considered, play an important role, and CO2 levels affect our brain and work performance. So what are the safe levels of CO2 in rooms, and how do they affect us? 400 parts per million is the normal background concentration in outdoor ambient air. From 400 to 1,000 parts per million are typical concentrations of typical occupied indoor spaces with good air exchange. At 1,000 to 2,000 parts per million, we see signs of drowsiness, which is caused by the poor air quality. At 2,000 to 5,000, we see headaches, sleepiness, and caused by stagnant, stale air. Poor concentration results in loss of attention, increased heart rate, and slight nausea. 5,000 parts per million in most jurisdictions is the workplace exposure limit given in any 8-hour period. And above 40,000 parts per million, exposure of CO2 levels may lead to serious oxygen deprivation, resulting in permanent brain damage, comas, even fatality. What is demand control ventilation? A ventilation system that provides for the automatic reduction of outdoor air intake below design rates when the actual occupancy of spaces served by the system is less than the design occupancy. Every building in every room has a variable need for ventilation based on variable occupancy rates, also varying activities based on the type of buildings and the building usages, and also the time of year. As we have already established, poor indoor air quality affects performance levels. Demand control ventilation is required to prevent energy wastage due to unnecessary ventilation rates. For example, operating maximum ventilation where there is low or zero occupancy levels. Demand control ventilation utilizes various methods and environmental sensors to evaluate conditions and regulate ventilation. These methods include scheduling, occupancy sensing, light level sensors, humidity sensors, and air quality sensors such as CO2 and VOC. Let us look at these methods in a little bit more detail, and we can also see the positives and negatives of each method. Scheduling. Air exchanges are set based on estimated occupancy during normal working hours. This is a fairly dated method in today's world, and this results in potential wasted energy, especially with low or zero occupancy levels. And in today's world, normal working hours have changed quite significantly. Occupancy sensors. There are multiple technologies available. The occupancy sensors are used to detect human presence in spaces. This is difficult to detect the number of people and is mostly used for individual or smaller areas. This also results in energy wastage due to full ventilation rates in operation, regardless of the number of occupants. Light level sensors. Light level sensors detect occupancy when lights are activated or during daylight hours. The use of light sensors makes it difficult to detect the number of people present. Again, this results in energy wastage if full ventilation rates are in operation, regardless of the number of occupants. Humidity sensors detect increased humidity from increased occupation and activity. They are used more in confined spaces and where moisture is present, for example, bathrooms and kitchens. This method improves energy savings as demand control ventilation can be ramped up based on occupancy levels. However, there are limited applications and this method is designed for smaller areas or zones. The more accurate, reliable and common approach is the use of air quality sensors such as CO2 and VOC. There are multi-technologies available and CO2 levels increase based on increased occupancy. Sensors are used to detect levels of CO2 or VOCs in a space, and demand control ventilation rates are ramped up based on concentration levels. This is a great method for smaller and larger group spaces and results in increased energy savings, and the demand control ventilation system is only ramped up based on accurate occupancy or poor indoor air quality levels. According to a new study from the Harvard T.H. Chan School of Public Health Center for Health and the Global Environment in sunny upstate Medical University and Syracuse University, people who work in well-ventilated offices with below average levels of indoor pollutants and carbon dioxide levels have significantly higher cognitive functioning scores than those who work in offices with typical levels of CO2 and indoor pollutants. This is of paramount importance in crucial areas such as responding to a crisis or developing a strategy. By utilizing ventilation as needed, energy wasted can be reduced and plays an important role in energy savings within buildings as a whole. A test was carried out by a Minnesota high school to obtain air quality, energy, and subjective response data using an automatic variable ventilation system. A control system with both CO2 and temperature inputs was devised to control the use of outdoor air and energy savings. Energy savings of approximately 20% were found for this application and project. Belimo sensors, small devices, big impact. Belimo sensors are the perfect complement to our actuators and valves. We offer a complete line of field-level device solutions, including sensors for measuring temperature, humidity, pressure, CO2, and VOCs in pipe, duct, and outdoor applications. A universal design enclosure with unique screwless snap cover conforming to NEMA 4X or IP65 rated and are UL compliant. The range offers reduced installation and commissioning and reduced part number selection and inventory levels for our customers. All of our products are also backed by Belimo's world-class service and support. Today, I would like to discuss more about the specific Belimo sensors relating to indoor air quality and demand control ventilation applications. Sustainable sensors are paramount importance for ensuring sustainable indoor air quality, comfort, and energy savings. Many sensors in the market today drift over time. This sensor drift results in the comfort levels falling out of acceptable living or working conditions, resulting in occupants becoming unproductive, uncomfortable, unhealthy, and causes energy wastage. Belimo humidity sensors are plus or minus 2% accurate as standard across the whole range. This ensures the levels in the buildings are controlled to the optimum conditions and levels. The outputs can also be configured to measure enthalpy or dew point for optimum outdoor air ventilation, demand control ventilation, and building conditions. Humidity temperature combined sensors feature a complementary metal oxide semiconductor based on polymer capacitance sensing technology, which is not affected by high humidity, contaminants, and has a minimal and long-term drift of only 0.25%. Up to 4 active temperature measurement ranges, which is field selectable in the device, provides flexibility during installation and commissioning. The duct and outdoor sensors are available with BACnet, MSTP, and also Modbus communicating. CO2 sensors are also important for measuring indoor air quality and important for demand control ventilation. However, CO2 sensors are subject to drift, and it is a necessity for sensor recalibration after a certain amount of time. These calibration methods can include a manual calibration, which is not always practical, ABC logic, and also a dual channel technology. The Belimo dual channel self-calibration technology allows the Belimo CO2 sensors to be used for all types of buildings and all applications where ABC logic cannot be used, even if the buildings are occupied 24 hours a day, 7 days a week. For example, nursing homes or hospitals. The Belimo air quality sensors equipped with the dual channel self-calibration technology ensure accurate measurements of indoor and outdoor CO2 levels. They are multi-sensors with optional integrated temperature, humidity, CO2, and VOC sensors all in one unit and are maintenance free. BACnet MSTP communicating and a large LCD are also optional within the range. Let us look in more detail about the difference between ABC logic calibration and also the dual channel calibration technology. You'll see the different ABC logic on the screen towards the left, which is a single light source, single wavelength sensor, and on the right we have a single light source, dual wavelength sensor, which is the dual channel. So if we look at this in a little bit more detail, CO2 sensors employing the single detector element, like ABC logic on the left, typically utilize gas concentration correction software with the assumption that the CO2 concentration in unoccupied spaces is approximately 400 parts per million. However, in an environment where many occupants are present at all times, 24 hours a day, 7 days a week, or when CO2 concentration remains in excess of 400 parts per million, ambient CO2 concentration never falls below 400 or falls to 400 parts per million, resulting in less accurate measurements due to inappropriate software corrections. The Belimo dual channel technology employs two detectors, each having a different optical filter in front of each detector. The first detector measures the intensity of the transmitted infrared light of the wavelength region that is absorbed by the CO2 gas. The second detector measures the intensity of the transmitted infrared light of the wavelength region that is not absorbed by the CO2. We call this the reference wavelength, and this is unaffected by CO2 concentrations, thus enabling effective correction of CO2 measurements. Belimo also offers volatile organic compound sensors, VOC sensors. And the technology is also important for indoor air quality and demand control ventilation. The Belimo VOC sensors measure a wide range of gases based on heated catalyst principle and gives us the ability to measure and control ventilation rates. Let us now look at how pressure conditions can affect indoor air quality and demand control ventilation. Maintaining a low building pressure allows untreated air to be forced into the building, resulting in unwanted temperature, humidity, and also pollutants from outside, creating poor indoor air quality within the building and demand control ventilation being required. On the other side, with high building pressure, the conditioned indoor air is now forced out of the building, and the control system struggles to maintain comfortable set points within the rooms and buildings, resulting in energy losses and inefficiency. By maintaining positive pressure of 0.05 to 0.1 inches water column, this supports in maintaining balanced levels and an excellent reason why an accurate, stable, reliable, drift-free air differential pressure sensor is essential. Belimo's 22 ADP series differential pressure sensors offer high accuracy of plus or minus 0.004 inches water column or 1 Pascal, and also offers 0-point stability. The 22 ADP pressure sensors are calibrated and tested during and after the production process, and all accuracy stated are the total error band. This is the typical tolerance, including repeatability and temperature dependence tolerance, and is not the sensing element component accuracy. All devices have 8 field selectable measuring ranges in one single unit and can be configured using dip switch settings to read inches water column or Pascal, depending on your region. optional LCD and Modbus communications, and as with all Belimo sensors, the accessories are all included, for example, plastic tubing and also the pressure probes in this instance. One major unique feature the 22 ADP has versus any competition is what we call true auto zero calibration, which ensures precise monitoring of critical air pressure. So what is this true auto zero calibration that we speak about? And how does this differ from other manufacturers' manual auto zero push button feature? First, let's look at the application. How often do you think pressure sensors or transmitters need to perform an auto zero function? For most applications, it is required periodically throughout the year or the years. But for critical applications, it is recommended 2 to 3 times a year. The true auto zero calibration from the Belimo 22 ADP electronically adjusts the transmitter's zero every 10 minutes. This function eliminates all output signal drift caused by thermal, electronic or mechanical effects, ensuring high accuracy and repeatability without the need of a technician, and also eliminating site visits or manual push button auto zero calibration 2 to 3 times per year. For further information on guidance and standards for energy efficiency and ventilation rates, please refer to the ASHRAE codes 90.1. This standard provides the minimum requirements for energy efficient design of most buildings. And 62.1 provides the standards for ventilation and indoor air quality. Belimo sensors, small devices, big impact. The perfect solution for demand control ventilation, indoor air quality, and energy savings. Thank you for taking the time to join me today, and I look forward to answering any questions you may have.
All right. Thank you so much, David. For those of you who joined us partway through the webinar, we do have a question and answer session. In order to ask a question, what you need to do is open up your question box, type in your question, and I will read it aloud, and David will answer it as best as possible. If we don't get to any of your questions today, rest assured we will be contacting you directly to provide you with those answers if we can't do it on air. All right, David, are you ready for the first question?
Sure, Michaela. Let's go ahead.
Okay. Do you offer 3% and 5% humidity sensors also?
No, we offer 2% across the range at a competitive price. This simplifies the ordering and part number selection and reduces inventory levels too. So 2% across the range is standard.
Okay. Next question. Which sensors do you offer in BACnet? It's very interesting for our integration.
For BACnet, BACnet MSTP only at the moment, and they're offered in duct humidity, outdoor humidity sensors, which is combined with temperature, but also with the duct CO2, temperature, and humidity in one device. So temp, humidity, CO2 with BACnet 2.
And so I have a specific product question. The 22 ADP pressure sensor, our Modbus, are they also BACnet as well?
No, just Modbus for now.
Okay.
However, we will be considering offering in BACnet in the future, but no timelines or decision as yet.
What is the warranty period of sensors? Is it the same as the actuators?
Yep. Sensors 5-year warranty, same as actuators and all Belimo products. Calibration accuracy for humidity and CO2 is 2 years.
What ranges does the CO2 sensors have?
CO2 sensors, currently we offer 0 to 2,000 parts per million, which is sufficient for the demand control ventilation application. We have just introduced a higher range of 0 to 5,000 parts per million, which is now available with duct, CO2 and temperature combined sensors, which would be required for any grow farming, any ripening of fruit or marijuana plantations.
Does the air differential pressure sensor have manual calibration as well?
Sorry, can you say that again?
Sure. Does the air differential pressure sensor have manual calibration as well?
Okay, so the air pressure sensor has the true auto zero, which does it automatically, but yes, if needed, the technician can push the button. There is a manual push button where you have to disconnect the tubing, disconnect power supply, reconnect, and there's a push button which you can hold to reset the sensor drift, yes. There is a manual that comes as standard. The true auto zero you can order optional.
Are the dual channel sensors more expensive than the ABC logic technology?
In the market, typically ABC logic would be more cost effective. Belimo only offers the dual channel, and I believe we are competitive versus ABC logic, and you know, the dual channel is essential for certain applications, as I mentioned, nursing homes, hospitals. So yeah, I think we are definitely competitive with the dual channel, for sure.
Okay, I'm going to do a last call for questions. Like I said earlier, if we did not get to your questions, we will reach out to you and provide you an answer at a later time. David, are you ready for the final question?
Sure.
How accurate are the air differential pressure sensors?
Air differential pressure. We have 3 ranges. If I think I can go back to the slide. Here we have 3 models for the air pressure. We have a 0 to 1 inch range, which has 8 selectable ranges in, and the accuracy of all those 8 ranges is plus or minus 0.004 inches water column. But then if we go to the next higher range up, which also has 8 ranges, is what we call the 0 to 10 inch model. The accuracy of that is plus or minus 0.02 inch. And then we have a larger pressure range unit, which is a 0 to 28 inch. Here we see up to 8 inch plus or minus 0.04, and above 8 inch plus or minus 0.1 inch water column. So 3 options, and the lowest range 0 to 1 inch is plus or minus 0.004 or 1 Pascal.
All right, so this concludes our webinar for today. I want to once again thank you so much for spending your afternoon with us, and thank you so much, David Alaban, for that excellent presentation. We always appreciate you attending our webinars, and we look forward to you participating in them in the future. If you should have any recommendations or requests for future webinars, feel free to email me and we'll take those into consideration. We are in the process of planning our 2019 customer webinar calendar, and we look forward to hearing from you. Thank you so much, everyone, and have a great day.